In previous video, we talked about permutations, but in this video, we will discuss combinations. First of all, we need to understand the difference between permutations and combinations. So what is permutations? We saw that in the previous video, but we did not compare both of these concepts. So first of all, what is permutations? I will not talk about the detailed definition, but only the difference between two. So permutations is something where order matters. If you do not understand why, what is the order matters, or why we use this concept, just pause for a moment and we will go to example and solve this problem. Solve some example and try to understand permutations. The next concept is the combination. So what is the meaning of combinations? And we will discuss in detail with some examples and derivations what is combinations. So the combination is something where order does not matter. Order does not matter. So what is the meaning that order matters and order does not matters? In that case, when we discuss permutations, when order matters, it means that if we have written AB and BA, then these two are different objects. But when we say that the order does not matter, it means that AB will be equal to BA. Since order does not matter, it means that physically, if two persons are standing in a queue, then this 1 and 2, in combination's point of view, they are equal. Either 2 will come first or 1 will stand in second position. Let me just go to example on this concept and we understand the combinations. One thing we must understand before I move to example, there are some scenarios where permutation is important. For example, it is important to schedule a train or any other transport. But in other cases, sometimes we are not interested in all the combinations, but we are only interested in or distinct, unique, unique or distinct objects. Suppose if we want to make a team, cricket team or any other hockey team, then you cannot make permutations, you make combinations. So let me just go to example and then we derive the formula for combination. Example, suppose we have a set. The set is A, B, and C. And if you are asked to find the permutations, then you can easily find all the permutations. And we know that the formula for permutation was NPR, but here uh, we we want to make permutation of two r is equal to two objects. So it means that there are three elements, total elements, and from these three elements you want to make a combination or set of two. That's how we write the permutations. So what is permutations in that case? In that case we have AB, BA, AC, CA, BC, and CB. These are all the combination or permutations or arrangement, I should say. These are all the arrangements of set of 2. This is set of 2, this is set of 2, set of 2, so on. These are all the permutations which is equal to 6. And here you can see that in permutations, order does matter. Now, if I talk about the combinations, and if you're asked to find the combinations, for combinations, what you can do is you neglect all the elements which are where the order does not matter. For example, here this is AB. In combinations, AB is equal to BA. It is the same thing. So then we have the first combination, which is AB. Then the second combination we have is AC. And then the last combination we have BC. Since AB is equal to BA, so it is neglected since it will repeat the object. AC, that is also equal to CA, since order does not matter. When order does not matter, so AC will be equal to CA. So you can see that in permutations we have 6 elements, and in combinations we have three objects. And the combination, or I should say the formula for combination, we will talk about that, but let me just go straight into the formula for the combinations. We know that NPR, which is permutation NPR, that can be written as PNR, it will be equal to n factorial divided by n minus r factorial. We already derived this formula in the previous video. Here you can see that in combinations some of the elements have been removed due to the redundancy or repetition. So how can we write the formula for combination from the permutations? We know that if we have r is equal to 2, if we have r is equal to 2, then it means that we can have 2 factorial, we have 2 factorial as an arrangement. We can have 2 factorial arrangements. Now, if we have two factorial arrangements of all these, it means that we can divide permutation with our factorial to remove the repetition in the permutation. So the formula for combinations will be equal to NPR divided by R factorial. NPR is n factorial R factorial n minus R factorial. If you just want to check whether this formula is correct, we can see that for this particular example, we have n is equal to 3 factorial, R is equal to 2 factorial, n minus R, that is factorial, n minus R, n is 3 minus 2 factorial. So this will be equal to 3, 2, 1 divided by 2 factorial and 1 factorial. 2 factorial will be cancelled out, and then we have 3 combinations, and you can see that we have 3 combination for this particular example. But in indirect way, we also derived the formula. There is a derivation for this formula from this example. So finally, we have the notation, which is NCR, that can be written as CNR, and the formula is n factorial R factorial and n minus R factorial. So this is the formula. I hope you understand this concept of combinations. Remember that R will be equal to 0, it will be greater than or equal to 0, but it can also be equal to n. So what we understand until now is that the combination is unique. It is unique or distinct. And permutations are all the arrangements. This has a consequence in our daily life. So let me just go to the corollary. First, we have one corollary. We also need to understand some mathematics of combinations and permutations. So here I'll talk about the combinations. So the corollary 1. The corollary 1 says that C and R, combination of n objects with R subset, will be equal to C n minus R. So how can we prove that? The proof is very simple. First, we write the definition of CNR, and CNR equal to n factorial R factorial n minus R factorial. And the next thing is we replace this second component of this value as n minus R, and we also replace this R with n minus R, and the same thing is for R. So we can write it as C n n minus r, that is equal to n factorial, and r is n minus r factorial. N minus, we should replace the second argument of this combination, which is r. R will be equal to n minus r, n minus r factorial. So we have n factorial, n minus r factorial, and we have r factorial over here. And if you identify that on the left hand side we have Cn n minus r, and on the right hand side we have this formula, and the same thing that we get on the right hand side as this thing, which is CNR. So that is equal to CNR. So CNR will be equal to Cn n minus r. So let me just go to some example over here on combination example. The question has been asked, how many ways are there to select five players from a 10 member tennis team. Okay, so this is the question. Now you know that if you want to make a team, for example, if you want to make a team from three people, and you want to make a team of two persons, so you need a distinct element for the team. If this is A, this is B, if you apply permutation and change the order, this is B, this is A, so it will not give you any new information. So it means that we cannot apply permutation in that case. We need a distinct team that we can make from 10 members tennis team. So in that case, we identify n is equal to 10, r is equal to 5. So C 10 5 will be equal to 10 factorial. Then we have 5 factorial, 10 minus 5 factorial, and from here you can solve it and get 252. There are 252 ways in which you can make a distinct tennis team of 5 players. So here I repeat, we need distinct team. We do not want a team which repeats. For example, in one team, if we have A and then we have B, but you cannot have the same team if it is B and this is A, so these are the same team. We do not have something new. Okay. So this was about the combinations. Let me just go to one other example, I guess. Let me just go to another example. Okay. Another example, a video is a bit longer, but if you want to understand this concept, then you should watch the complete video. So example is suppose there are 30 people, a group of a group of 30 people have been trained have been trained as as astronauts astronauts to go to Mars. How many ways how many how many ways are there to select a crew of a crew of 6 people? So this is the question. Now you want to make a team, a distinct team from 30 people. Okay, so how many ways are there? So we apply combination C. Total we have 30 people, and from these 30 people you want to make a team of six members. Since we want to make a distinct team, so team should not repeat. So we have 30 factorial divided by 6 factorial, 30 minus 6 factorial, and after solving that we get 593,775. These are the arrangements for such a 6-member crew. Okay, one other question. We want to solve as many examples so that we understand the concept. Example. The question is, how many ways are there to select a committee consists of 3 faculty members, three faculty members, 3 faculty members from mathematics, and 4 from computer science, and 4 computer science, 4 computer science. This is the question. And if we have a total math faculty, for example, I just write the number. Total math faculty, it is the part of question. Faculty is equal to 9. And the computer's total computer science faculty is equal to 11? So this is the question. So you want to make a committee of from 9 people of math department and choose 3 from them, and similarly 11 from 11 computer science faculty you want to choose 4 out of them, and you want to make a committee. So we need distinct elements. So the first combination, for example, will be from math. There are total 9 faculty members, and if you want to send 3 faculty members in a committee, so there will be 3 members. Then we also have C, that is, we multiply these two combinations. If computer science faculty is 11, and from these 11 you want to send 4 faculty member for to part of that committee, and we need all these different ways to multiply together so that we can get total ways or total number of ways, total arrangements to form a committee. So for that, the answer is 9 factorial, 3 factorial, 9 minus 3 factorial. This is 11 factorial, 4 factorial, 11 minus 4 factorial, and at the end you get 27,720 ways to form that committee. So this was all about the combinations. Thank you for watching.